Hey everyone, welcome back to MLWorks. In this video, we'll be talking about FastAPI and databases. So we'll be building two FastAPI applications. One is synchronous, the other is asynchronous. And once we have built those applications, we'll be using Locust, a load testing tool for testing those applications and understand what will happen when there is high traffic and where there will be more failures in terms of handling the request. So before we get started with implementation, what we'll do is we'll discuss what is ORM and then we'll talk about synchronous and asynchronous database calls. ORM stands for Object Relational Mapping, meaning it will try to act as a layer between FastAPI and the database such that you can communicate between these two with the help of Python objects or methods or class. So this will kind of help you to create database or handle creating table or pushing data into the database with the help of Python code. So for FastAPI uses SQLModel as ORM, which is built on top of SQLAlchemy. And SQLAlchemy is also an ORM which is widely used for complex application. Now, when it comes to synchronous and async database calls, consider, right, you have a database you want to query. So what will happen is when you are querying, okay, it uses something called as worker. Now that query, unless it is completed, there cannot be another query made. So it is waiting for that query to complete, then only you can make another query. So this is a synchronous database call. When it comes to asynchronous database call, you make a query with the help of the worker. That query is then left out. It is like kind of going on its own thread. The control comes back to worker. Worker can also handle other requests as well simultaneously instead of just waiting for that query to complete. So that is the key difference between synchronous and async database calls. So we have different libraries for that. You can use any of these libraries for a synchronous call or can build the database with the help of these libraries. Asynchronous database, you can use any of these libraries. So now what we'll do is we'll go ahead and implement our two applications. First is async and there is synchronous application. So these are the dependencies. So we import them. First is FastAPI, which is our main class for the app, and there is depends, which is the dependency injection. What it will do is consider, right, when you are hitting an API endpoint, there might be some dependency for that query to execute or some that call to complete. So that dependency is managed with the help of depends module. Now comes typing. This is type hints generator and async generator. This is used for managing the database session. And then we have SQLModel and SQLAlchemy. So these are different modules for managing the session, creating the table, running the query. Okay, so all these are done with the help of these different modules. So let's first start with creating a data model or a Pydantic model or a SQL model. So all refers to the same thing. So let me create a data model first. So I'll be creating hero, name of the class, and it will be importing or inheriting the properties of SQL model, and we want to enable table as true. Then what we do is we start adding the attributes to this specific data model, which is ID. It is an integer and it can also take none value, or we can also give certain attributes to this specific ID, which is this is the primary key. So how to do that? So none is equal to field, and then we pass in the default as none, and then we say the primary key has true. So for this table, ID is the primary key and it will be unique. So next is we can keep name as string. Then we can keep secret name as also string, and then age of the hero is we don't know it is an integer, but it could also be none if it is not provided. Now we have created a class or a data model for both synchronous and asynchronous application. Now what we'll do is we'll start off with async app. I'll be using database URL for the specific application. So database URL. So since it is a asynchronous application, I'll be using a driver which is compatible for asynchronous application. So it is SQLite plus AIO SQLite, and then this is the syntax for creating the DB. So this is test async.db, and then we have to create the engine. So we use for asynchronous, we have to use this engine which comes from SQLAlchemy. So async underscore engine. So create async engine. We pass the async database URL and echo has false. We don't want to look at the logs while it is getting executed. So this is done. Now we want to create database table and database also. So what we have to do is we can use async def create, then we have to async db and table. So this is the function name, which is asynchronous function. It doesn't take any parameters. Now since we have asynchronous function, we also have asynchronous scoping done here. Async with asynchronous engine dot begin, and it will be turning this will be our database connection in a sense. So once the connection is created, we have to run the query, which is run sync, and then we have to send SQLModel dot metadata dot create all. So this will execute the query and it will create the DB and table. Now we have created database table and DB. Then what we have to do is we have to create asynchronous session. We have to create the app. So before we do that, let me just go and refer here. What is the template here, right? We have. So we have created the sync. Now we want to create the lifespan. So we want to create lifespan here. So for that, what you have to do is async. Before we do that, we have to use the decorator async context manager. So this will ensure the startup and shutdown of the FastAPI application. So once we have given this decorator, then we have to define the function for async lifespan. So here we'll be taking, since this is for the app, so it should be app : FastAPI. Now since it is start and end is there, then we have to give starting, this is async app creating tables. So here we have to make a call to this specific function, and this will also be under await command. So understand this, right? So the reason why we put this under await command is because we have this application getting started, and this is a separate function. Okay, we don't want to interfere one with the other. Okay, so we create a non-blocking IO where this is with the help of await keyword. So this will run separately and it won't interfere with the main application. So next is yield command, and then print of shutting down async app. So we are done with this, and then what we have to do is we have to create how to generate asynchronous database sessions. So async def get async sessions. So here we have to, I have to guess, here we have async generator followed by async session. and none. So this is kind of done, I guess. We just have to keep creating sessions as the API gets called. So async with, then we have to async sessions, and we have to use async engine here somewhere as session, and then we have to keep sending out the session. Okay, so this is how you have to define asynchronous session for asynchronous application. So once this is done, we have to start our FastAPI application or kickstart our FastAPI application. So app underscore async is equal to FastAPI. Then we pass our async. Before that, we have to mention the lifespan as async lifespan, and the title is async API. So this is done. Now what we have to do is we have created the app. Now we want to add API endpoints to it. So what I'll do is first app underscore async. First we have to create the post method, then only we keep adding heroes to with the help of post method. So under post, what we have is, I guess we have to add let me go on the path. I guess we have to show the path. What is this? Is async heroes, and then the response model, which is again a hero, and then define the function for creating. So since it is asynchronous application, async create hero. So here I'll be taking in parameters like session. So this is positional argument that we are sending first, and then keyword argument. This is async sessions, and which will take in dependency, and the dependency is get async session. Now it also takes a parameter which is hero, the class hero. So once this is done, what we do is we do add the hero to the session. Once that is done, then we await and do session dot commit, and then await session dot refresh, and pass update the ID of hero object, and then return the hero. Now without writing the whole thing again, I'll just copy and paste it here and turn this into a get request, and response model will be, it won't be hero, it will be list of hero, because already heroes are present inside. Now we want to get the list of heroes outside. So it won't be like this. No, I won't be taking in any input here since it's a get request. And here we have what I would call, it's not like this, we have to move this. The result is equal to session dot execute. It's execute or exec something. So let's wait, if something comes up, if error comes up, we'll change it to exec. So this is hero now. Okay, this is done. Now we want to get the heroes. So what we do is result dot scalars dot all, and then return heroes. Now there are certain changes, I guess. One is, this is async definition, so we want to keep this as await command. I think we are good to go. Now we are done with asynchronous application. Now we want to create synchronous application. So what I'll do is, let me do sync application. So I'll just copy paste most of the things from here and modify everything based on the synchronous application. So first is I don't want AIO SQLite. So this is done, this is done, this is async, then async sync engine, then I don't want this one create async engine, this is create engine. Okay, so this is 2 line is done. Now there is no asynchronous function is required, so we remove this. So we can directly, we don't even require all these things because we can directly run this engine inside this command where you can just create, or probably let me go back to this reference document for synchronous, right? So we have this command can be created, so there is no point in creating it like or like this, because at the end what we are doing is we just have this one line inside this function and it's getting called here. So what we are doing is correct, so we can keep it like this. So this is just a print statement for our understanding. Starting sync app, creating table. So let me go back here. So yeah, we are done with this. Now we can start with our app API. So let me go here. So we don't have anything like lifespan for synchronous application, so we skip this step. We don't want this also. Now since there's no lifespan, this is also not required. Just turn this into sync API, and this is app sync, and this is also app sync. And what we do here is instead of async, we turn it into sync heroes, correct? So this is we starting the app, and here we are creating the app. Then what we do here is instead of async session, we have regular session, which is this one. So if I just copy this, right, session is equal to session colon session. Okay, so this is what we have to do, and instead of async session, we have sync session. Okay, well, let me just look back here for a moment. Okay, so this is there. So we have get, let me copy this directly. This is similar to what we have done earlier. So instead of async generator, we have generator now, and it will return synchronous sessions. So we use this as our synchronous session here and here. And then these are the set of same steps. We no longer have, so this is not required. This is sync now. So session dot commit and refresh hero. Okay, and then here also we don't longer need async, and we no longer need await. So since this is happening, we don't longer need scalars as well. So yeah, we remove the session async session to session now, and dependency is same. Yeah, I think we are done with synchronous and asynchronous application. Now what we have to do is, since there are two applications, it has to run on two different ports. So I'll go here now. Let me maximize this. Change to documents, ads, explore libraries, FastAPI. Now UV-con, and we have our main file, and then we have our app name, which is app_async. It is running on port 8000, and the number of workers that we are assigning for this app is 1. So let us run this. So there is some issue here, right? Async connection was never awaited. Okay, wow. So let us see, we'll see. Since the application is running, let's not worry about it for now. Now let's again copy this and paste it here. Instead of async, we have sync, and it is running on port 8001. Number of worker is 1 again. So yeah, this is also done. Let's go to incognito in our browser, localhost 8000. We have our two APIs running, localhost 8001. So we have our two APIs running. Now let me go back here. Let's see if something, yeah, it's 200. Okay, it's fine. Since I said we'll be testing out the application once we have built. So we'll go to Locust. So let me maximize this. So we have Locust file here. If you see here, right? I have a Locust file. I'll open it here. So the Locust file, what it will do is it will import HTTP user, which will be our simulated user, which will hit the endpoint. That is the task, hitting the endpoint, and between is the pause that we have to take in between, just like how the realistic user will be hitting the API. So we have async port is 8000, synchronous port is 8001, and this is the class, and this is the virtual user that we want to create and hit the API with. And this is the host address, and this is where we want to hit the endpoint. So just for a confirmation, right, this is the heroes. This is heroes. Let me go back here and see. This is heroes. Yeah, correct. Yeah, this is also correct. Don't have to worry about it. Now what we'll do is we'll just spin up our Locust UI. So here I have to pass the file name. So let's see. So we have our Locust running here, copy it and paste it here. So I want to ensure as the traffic increases, the app should not drop the request that I'm sending. It should be able to handle it. But the problem is synchronous application may fail certain cases as the number of user increases and the load increases, while the asynchronous application should be able to manage the number of users or the higher concurrency. So I'll be first testing it out with just 5, ramp up time of 1. Let's start. So yeah, so there is something wrong with asynchronous app that we created. So everything is getting failed. So I'll stop this for now. I'll go here. Let's see, this is where I'm seeing something going wrong. Okay, so the problem is I think here we don't have await key. So let me paste it. So again run this one, async app. Now what we can do is reset new and again start this off. So now if you see, there is no failure and it is running as expected. Now what we can do is if I go here, right, you will see, so we are getting 200 when we are calling this specific API. So let me go to this one. Now I'll stop this. Now I'll increase the load. Instead of 5 user, 200 user. Ramp up is 1 second. I'll start again. So while this is taking place, right, after a few minutes, we'll be seeing number of failures that is happening with respect to each app. So let's wait for a few minutes. So I've stopped the execution and there were like around 70,000 requests that were sent. And if you see, there are more number of requests that were handled by async API. It is 35,000, almost 36,000, and this is 35,000. Around 500 more requests were handled by async, and the time taken is pretty less compared to synchronous API. It is around less than 6 millisecond. It is 6.6 millisecond for synchronous API. So the thing is, as you increase the load, there will be a very good chance the synchronous API will start seeing failures in terms of the request that you are sending, and you might end up having few failures. And if you are sending the same number of requests to the asynchronous API, it will be able to handle it because of the asynchronous nature of it. So we have built, okay, let me go back here. So we have built 2 apps, synchronous and asynchronous, and we also tested with the help of Locust tool which apps perform better when the load is increased. So with that, I'll be concluding this video. Thank you for watching.